In continuation of what we discussed in the previous videos, here we are going to make our simulation model in an Excel file. In the first column, we have inter-arrival time that is uniform, continuous probability distribution between 0 and 5. So when I want to simulate this part, it would be easy. It would be just this rand function times 5. We have talked about all these things before. 5 is because of the range, because of the length of 0 to 5, and why we don't have any lower bound in this uniform random number generation, because it is 0. So it is the inter-arrival time, so I can populate it for the remaining 1000 scarf. So it's gonna be something like this, and now you can see I have all the simulations for the inter-arrival time. Okay. The other one is the arrival time. Okay, see, when you want to simulate arrival time, as we talked about it before, for the first scarf, it is 0 plus inter-arrival time. Why it is 0? Because it is the first scarf, and always for simplicity, we start our simulation from 0. So for here, I'm gonna type this. Arrival time of the first scarf is equals 0 plus the inter-arrival time. That's it. What about the second arrival time? The second arrival time that we have here is the arrival time of the second scarf. That equals to arrival time of the previous scarf plus inter-arrival of this scarf. If you cannot catch up with these things, I suggest you check the previous video. Okay, and we got it like this, and now we can I'm going to show it for this one also. Arrival time of the scarf 3 equals to arrival time of scarf 2 plus inter-arrival of 3. And so we get this. And now we just need to populate this, and now you see we have it for 1000. And if, for example, I go and check this one, you see it says D382 plus C383. So it seems that it is the summation of these two things. That is the arrival of the previous one plus the inter-arrival of this one. The point that you can see, the arrival time is always increasing. That makes sense because your simulation starts from 0 and continues to 5, 10, 1000, and it depends how long you want to continue. You see, these things always are increasing because it's the time of your simulation somehow, and it is increasing. But about the inter-arrival time, it is not increasing because it's a random number between 0 and 5. And if you see, all the random numbers that we have in this column are between 0 and 5 random numbers, and they are not increasing. And another point, you may wonder why I'm doing 1000 of the simulation simultaneously, because now you have experienced one case of simulation, so now you are more familiar with this field, so we can do it in more handy way. The next item that we are gonna tackle in this simulation is service time. Service time checks that when a scarf goes into inspection service, how long does it take? Okay, according to the problem description, we know it is a normal distribution with mean of 2 minutes and standard deviation of 0.5. Okay, so we are gonna simulate it in this way. You already know how to simulate normal distributions, and service time is normal, and you have the mean and you have standard deviation. So of course, very easily you can simulate the service time for 1000 scarves that we have here. So it's gonna be norm, the help pops up, and I'm gonna click on that norm for the probability. Since it is random, we are gonna put rand, and mean is 2 and standard deviation is 0.5. Okay, now we can populate the rest. And again, for the service time, if you check, it is not increasing because it's a random number. It's a random number that most of the numbers are around 2, and when they get farther from the mean, that is 2, the associated probability decreases. And now here you can see the service time. For example, it says that according to the random numbers that we have generated, the service time for scarf 104 is 2.29 minutes. Or for example, for a scarf 363, the service time is 2.40. Now that we have service time and arrival time, okay, we can work on service start time, this column here. Okay, for the first scarf, the service start time, since there is no previous customer, is exactly equal to the arrival time. So for the first customer, for the first scarf, the service start time is 4.83. Why? Because scarf 1 arrives into the inspection station at 4.83. About the next one that we want to do, as we talked about it before, in the previous slides, it is not as straightforward as this one, because when you want to see when the service to scarf 2 starts, it depends on the previous one. It depends if there are some other scarves in the line. If there is no scarf in the line and scarf 2 is the only one in the system, of course, it would be equal to its arrival time. But what if when scarf 2 arrives at time 9.71, there is a still service of scarf 1 undergoing? So we need to calculate the completion time to see when the service of scarf 1 is completed. The completion time for scarf 1 equals to service start time, makes sense, plus service time. And we have this. Because we want to calculate the completion time of a service. For example, we talked about these things, but again, as a review, because we are doing a model for simulation and it's always common sense. Okay, when you have the start time of the simulation as here, and you have the time of the service, when you add these numbers together, the service start time and service time, you get the completion time. Okay, now you have the completion time, my friends, here. So you are completely good to calculate the service start time for scarf 2. Okay, scarf 2 arrives at 4.97 and completion time of scarf 1 is 1.94. Go to your common sense. When the completion time of scarf 1 is 1.94 and the arrival time of scarf 2 is 4.97, beyond the completion time of the scarf 1. So in this situation, scarf 2 doesn't need to wait, and the arrival time would be equal to the service start time because scarf 1 has already left. So how we are gonna tell it to Excel? We know that here we need to see the number that is here, okay? So we are telling the Excel, hey Excel, put for me here maximum of these two values. What are these two values? Completion time of the previous customer and the arrival time of new customer. Either one is bigger, that is the service start time. So now check. The completion time for customer 1 for scarf 1 has been 5.52 and the arrival time of scarf 2 is 6.55. So the start time would be 6.50 time. So here about the completion time. Completion time is always service start time plus service time. It's a general fact. It's although to calculate the completion time you need to have service start time, that it's a little bit tricky, but these two things are related to each other. So what do you think if I drag this formula down like this? And so for all of the cases that we have, for example, let's go to this example. For all of them, I'm telling Excel to calculate the completion time, add up these two columns together. One of them is service start time, and the other one is service time. So service time plus service start time is that. But now that I have put this formula, I need to go and also calculate the completion time for all of them. For service start time. Again, for this one, I want to show you the service start time equals maximum, the service start time for scarf 3 equals to maximum of completion time for scarf 2 and arrival of scarf 3. So here, oh, I missed it. It would be maximum of completion time of scarf 2 and maximum of completion time of scarf 2 and arrival time of scarf 3. And in this case, you can see the completion time of scarf 2 is after arrival. So it means that scarf 3 needs to wait. How much? We are going to calculate it. Okay, and that's it. And when I go over this, you see it is maximum of G3, D4, G4, D5. So everything is the same, just the indices are one more because of the rows index. So you see it is about G and D, it is also about G and D, and it is 4 and 5, it is 3 and 4. So this formula could be extended to the rest, as you can see. What about the service start time? As you can see, of course, it is increasing, my friend, because it is a simulation and it tells you. And now you are ready to calculate the waiting time. The waiting time, it is calculated according to, again, a common sense type of formula. Now we are back to our slides to check the last part. It is entitled, let's finish the simulation, because we did it more on the Excel file, and here it is about waiting time.